So 71st question is, which technique is commonly used to visualize and manipulate individual atoms and molecules on surfaces? So here they are telling that individual atoms. So in individual atoms, X-ray will not can't detect the individual atoms, but this is for the bulk structures. X-ray is also as for bulk structures. So here it is wrong. So next, second and third will be the scanning electron microscope, which will be the SEM and TEM. This is for surface morphology. This is both for surface morphology. So here imaging at a small scales, but not for a manipulate of the individual atoms. So the answer will be the fourth one, which will be the tuning microscopy. Scanning tuning microscopy. From the tuning microscopy, it can, for example, will be the moving xenon atoms to write the letters. So this is an example for the scanning tuning microscopy, which is called STM. Okay. 72. What is the term for a material that conducts electricity only in 1 or 2 dimensions at a nanoscale? So here first will be the nanowire, nanotube, nanorod and nanoplatelet. Okay, here we already know that what is nanotube. There will be the carbon nanotube, which behave like a quasi 1D conductor. So single walled carbon nanotube. Okay, here it will behave like a quasi 1D conductor. So it is like a conducts electricity, but only in 1 or 2 dimension. So here for the nanoscale, so that it is a singly walled. So we can't consider this because it is a quasi 1D conductor, but not a 2D. Okay. What will be the nanotube? Nanotube will be the nanotube is the right answer. Okay, nanotube. Okay. What will be the nanorod? Nanorod and nanoplatelet. These are the 2D analogy that conducts in 2D. This is for this 2 for 2 dimensional. This is for 1D that conducts quasi. But nanowire that conducts along 1 dimension also in a 2 dimension also. So that it is the right answer, because it is, since it is a nanowire, we already know that wire will be the conductor since it is a copper wire. So it is a nanowire that conducts the electricity. So this all are the similar pattern. So this will be the some of the extra properties nanowire. So that I choose this. Okay, 73. Which one of the following is an example of homogeneous catalysis? So here some of the reactions are there. So they are telling which one is the homogeneous catalysis. So first one will be the Haber process of synthesis of ammonia. We all know that Haber process, this contact process, both are the heterogeneous catalysis. Using of the heterogeneous will be taken place in both of these, and catalysis of the hydrogenation of the oils. Oils are also some kind of the heterogeneous catalysis, because here there will be the oils are for different nature, and this hydrogenation is of different nature. So that since these both are the different phase or different nature, since these are the heterogeneous catalysis. But in acid hydrolysis of the methyl acid, there will be the acid catalyst and reagents are in same phase, since H plus acts as a homogeneous catalysis. Since H plus acts as a homogeneous catalysis, here acid catalyst as well as reactants are in same phase. So that this is the homogeneous catalysis example. Okay, 74th. The elements which are good conductors and can change their oxidation number. What are they? Can change their oxidation numbers. Okay, first noble gas or noble elements. We already know that noble elements is always, they are always inert in nature. So they will not change their oxidation number, or they will not make any differences, since they are in a octet nature. They are always in a octet, so that they are stable and inert. Okay. Alkalis. We know that alkalis are the metals which are having the plus one charge, means Na plus like a Na plus, H plus, K plus, anything, alkali earth metals. So that they are also having the fixed oxidation number. They may change, but a little bit, not a gradual most number of change. If we come to the acids are not either in not they are in this class only. They are not a metal elemental also. They are mixtures. For example, HCl, there is a mixture, right? So acid are not in this class only. So the elements are considered as the transition elements, which are having the D blocks. So they can show the redox behavior, also multi oxidation state also. So we already know that Fe2 plus, Fe3 plus, okay, and many other transition elements also are there, which can change their oxidation number and enhance their properties also. Okay, which term describes the proportion of a drug that enters the systematic circulation and is available to produce the effect. So here they are telling the systematic circulation. So systematic circulation. Systematic circulation. So first we have to know that what are the definitions of this. Bioavailability is like the fraction of a administrated drug that reaches systematic circulation unchanged. So first only you know that bioavailability is the right answer. But let's see the next. Bioavailability is that bioavailability means a fraction, not a full, but a fraction of a administrated drug which will cause the effect. So that part only will reach the systematically with the systematic circulation and make the effect and produce effect. What is the absorption? Absorption is the phenomena or a process by which a drug crosses the membrane. So here there is no systematic circulation, but the crossing of the membrane will be take place. What will be the uh, distribution and metabolism? It is also a pharmacokinetics steps that alter the drugs level. Here the alteration of the drugs level will be take place for the distribution and metabolism, but not the proportion of the reaching of circulation. So this is the main thing. Okay, let's see the 76th question. Okay, 76th question will be this. What is the main function of beta blockers in our body? So here they are telling about the beta blockers. So mainly beta blockers is those which will beta blockers are those which will reduce the blood pressure. Third one, they will reduce the blood pressure since they will reduce the heart rate, which we call as a negative chromatrophy, something called as, so that they will reduce the blood pressure. So next will be the 77th question. Molecular cages capable to trapping the guest molecules are known as. So they are telling about the trapping of guest molecules, trapping of guest molecules. So that here we know that first is a fluorines, which is containing the carbon box, which is fluorines. Okay. Fluorines is a closed carbon cages that encapsulate the atoms, but not as a guest species. Okay, they can encapsulate the atoms, just atoms, but not guest molecules. They will not able to capable to case the molecules. Okay, next the zeolites. Zeolites are the porous inorganic framework, so that they are used for the water filtration and some of the other properties. Just inorganic porous, they have the porous nature, like the whole souls, like the holes containing like this. Porous nature is like this is the, and there is a some of the holes like this. So here some of, if there is a water content, there is a some of the highly metal, they can absorb this in the holes, so that the purification of water takes place. Like this zeolites are helpful, but not trapping the guest molecules. Okay, next will be the auxiliaries, we can discuss later. And next is protections. These are the mechanically interlocked molecules. So this is not trapping of guest molecules will be helpful. So third one will be the auxiliaries. These are the cavity that encapsulate the guest species, and also these are the helpful in the cancer molecules, and also many advantages are there for the auxiliaries. So that this is the right answer. Some of the auxiliaries and also chroniters, like this, many others are there which will helpful for the trapping of the guest molecules. Okay. Next question is also like that only. Which of the following is not commonly used for supramolecular host molecule? So they are telling that which is which of the following is not commonly used, not commonly used. So you already discussed that proether is used, and this is used, and carexit is also used. So that carboxylic acid is not used as a supra host molecule because since it is a acidic. Okay. Which region is greatly affected by the air pollution? Here, air pollution is affected by the troposphere. Yes, troposphere is a fourth one. Troposphere is affected by the air pollution since it is the lowest layer of our spheres. So that there will be the it is strongly affected by the air pollution, and there is some of the fog which is created by the pollution, and there is an impact on the air quality also. So it is all this all air pollution is related to troposphere, which is the lowest layer. If we come to the stratosphere, it is in the ozone layer, and if we come to the mesosphere, it is in the higher or less separated by the surface pollution or the air pollution. So it will be the troposphere which will be the affected by the air pollution. Okay. Next one will be the which of the following is the main source for the soil and water pollution. So here they are telling which is the main source. So here which of the main source will be the first will be the mining, and second will be the agro industries, and third will be the thermal power stations, and fourth will be the fishing. So here mining will affect the water pollution, but it may not affect the soil pollution, since there are the many other options are also there. So let's see. And agro industries. So here agro industry are the main, since it has the fertilizers and animal waste and runoff also there. So that agro waste are the main cause for the soil and water pollution. So that we can take the agro industries. Next will be thermal power stations and the fishing. So fishing not for the soil pollutions, and also thermal power stations are not. So you can explore these both, but difference will be about these mining and agro industries. So mining may cause the also air pollutions, also some of the other pollutions, but agro industries are the main cause for the soil and water pollutions. Okay, here they are telling about the decreasing order of the electronegativity of the atoms. So decreasing order, since we know that if we go from left to right of the periodic table, electronegativity will be increasing. So that here they are telling that decreasing. So decreasing order, since sulfur is the more electronegative, since it is a oxygen family. Then there will be the arsenic, which will be the nitrogen family, and then will be the aluminium, since it is in a 3+ state, and so it is in a here where it will come in the third group, and then there will be the Ca. So that 3 will be the right answer. If we come to the here first option, there will be the yes, and yes will be the last. So that oxygen, nitrogen, like this. So this is also wrong. And here there will be the they are telling that here it is will be right, but it is in a inverse manner. A will be the greater than Ca will be the greater than S. So it is also wrong. And here also this is oxygen family, and this is the nitrogen family. Middle it is in a metal. So that it is also wrong. So it is the right answer. It is a simple question, simple answer. You can easily identify this. And here also telling that the correct order of the size of a sulfur 2 plus, and sulfur 2 minus, and 2 plus, and sulfur 2 plus of the species. So here one thing we know that if we will add the electrons, then there will be the electron repulsion will take place. What? There will be a electron repulsion will occur. Since this electron repulsion, there will be the increase in the radii. Radii will increases. Since there will be the electron repulsion, there will be the increases of the electron. Hence, larger will be the radius. So, if there is a 2 plus, hence 2 minus. Hence, if there is a 2 minus, hence there will be the more electrons. So, more size. So, where is S here? 2 minus is greater than S, and S is greater than S2 plus, and S2. Since S2 plus S4 plus having the there is a less electrons of 4 electrons, so that it is having the less size. Since there is a electropositive nature, if we remove the electrons, then there will be the reduction of radius will take place. Okay, next will be the 83 question. 83 question will be the geometry and shape of the ICL3. So if we need to know that the I, and there will be the CL cell, which is like the T shape. You can know that this is means like this is the right T shape. Okay, one will be the T shape, and so there are only two options. Here also T shape and here also T shape. So it is not an octahedral, since there is no six groups are attached. So it is simply trigonal bipyramidal. Since it has since it has three bonded Cl and also two lone pairs. There is presence of the two lone pairs and three bonded Cl. Hence, lone pairs will occupy the equilateral positions. Here, lone pairs will occupy the equilateral positions, and three Cl will occupy the axial positions. So that here will be the molecule like this AX3E2 will be the molecule, so that it will be the right answer will be the trigonal bipyramidal T shape. This is the geometry and this is the shape. Okay, next will be the 84th question. The molecule that possesses the dipole moment is. So here they are telling that the dipole moment. So dipole moment will form when there is a two poles, dipole. So there will be a positive and negative pole. If we come to the F4, then there is a highly symmetrical, since there is a F4, 4 is there. And if come to the xenon F4, then there is also 4, since it is also highly symmetrical. And if we come to the CCl4, then it is also same groups are attached. And if come to the PCl5, then it is also. So all are having the same groups. Then which will be the correct answer? So there will be the slightly confusion is there. So that if we know the correct SF4 will having the seesaw molecular geometry, which will be the AX4E. So with that, there will be the unsymmetrical arrangement will be take place. Hence, there will be the zero net dipole moment will be take place. Hence, there will be the dipole moment will be take place. For these three also zero dipole moment will be there. And for SF4 will be there is a dipole moment will be non-zero net dipole moment will be take place. Okay. Next, according to the Bent rule, for the 85 question, according to the Bent rule, the correct geometry around P atoms and positions of the fluorine is. Here they have given PCl3F2. They are saying which will are come to the equilateral position and which are come to the axial positions, or how the arrangement of this take place according to the Bent rule. They are saying, so that we know that according to the Bent rule, atomic character which has the S character will have the more electropositive nature. So if there is a more electropositive nature, there will be the S electronegativity. If they are having the p orbitals, p character, they may have the more electronegativity. So that here which will have the less electronegativity, that will have the S character, and that will there in the equilateral positions, right? So that Cl will have the less electronegativity as compared to fluorine, right? Fluorine is the upward than the Cl. So that fluorine is the downward than that of the Cl. So that since fluorine is there, since it will there in the actual position, since it has a more p character. Right answer will be the fourth one, which will be the trigonal, bipyramidal, and axial. So this is the right answer according to the Benton. Okay, here they are saying the SBFI in HF is regarded as a so they are saying that the strong acid, weak acid, strong base, weak base. We all know that fluoroantimonic acid, which will be the super acid. So how can it will be the weak acid or a weak base like that or a strong base? So it is a super strong acid. So it will be the strong acid. Okay. Next will be the pH of 1 into 10 raised to minus 7 normality of the solution of HCl is. So they are telling that the 1 into 10 raised to minus 7 normality of the HCl. So they are telling this of solution of pH. What will be the pH of 1 into 10 raised to minus 7 normality of HCl? So that here it is will be the wrong, since it is a 7 will be the water, since it is the neutral. This is also wrong. And 4.5 will be the high level of the pH, since they are telling 1 into 10 raised to minus 7, since the pH of the HCl will be normal, will be 1 to 1.5 will be the pH. So if we come to the 1 into 10 raised to minus 7, it will 4.5 will be the high level. So it is also wrong. So it is in between 5.9 and 6.7. Since they are telling this type of the normality, so we can go to the 6.7. Since 5.9 is also some little bit slightly higher, so that we can choose 6.7. So this is also a technique to choose the right answers, like this also. Okay, next will be the option 88 question. Here they are telling that the isolable which of the which group is isolable with ReCO5. So here there are some of the elements. So we know that Re will come to the in a D7 system. That's right, D7. So there are the 7. So we can choose the consider C as a 4. Since it is in the fourth group, we can consider carbon as a 4 and plus 3. Since H is in a 3, so 5, 6, 7. So CS3 will be the correct, which will be the isolable, since 7 is isolable with 17, like this. So here there will be the rule called the octet. Octet is equal to or isolable, which will be the, we can make this type of thing mark, which will isolable with the 18 electron rule. So this will be the rule. If there is a 8 electron species and there is the 18 electron species, then it is a isolable with each other. So this is the concept. So 4 plus 3 will be the 7. So 7 and 17, which will be the isolable with each other. So 89th question. The hybridization of nitrogen and phosphorus in phosphorogen is, we know that phosphorogen is like the NP, 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 like this way, and there is double bond, single bond, double bond, single bond, double bond, single bond. Like this, there is the structure of phosphorogen. We know that. So here the hybridization will be sp2 and sp3. Since first one will be the correct. Since the nitrogen is a sp2 and phosphorus will be the sp3. Since there is a double bond and a single bond will be take place, where nitrogen contains the double bond and phosphorus contains the single bond. So since there is a double bond, hence there will be the again p orbital, and also there will be the since there will be the planar nature, so sp2 will be there, and for phosphorus there will be sp3 is there. Okay, for 19th question, acetic acid exhibit the following effect on the acidic behavior. So we know that acetic acid is a weak acid as compared to HCl. So that we already know that weak acid will not dissociate completely. So we have to they take knowledge of here they are given the some of the halogens, because HCl, if you compare HCl and if you compare for the hint, they have given this of the halogenic nature, so that here they will make the differentiating effect, since they will differentiate the strong acid and weak base. Here HCl will dissociate completely, that of H plus and H minus, but CH3COH, which is a acetic acid, will not make a complete dissociation, so that HCl will be the leveling effect, will make the leveling effect, but it is not a neutralization effect, and it is not a solution effect, which will be the water. So differential effect will be the acetic acid, which will make the differentiating between the strong acid and the weak acid when we put it in the water. Since water pH is 7 and acetic acid pH is near to 7, but if you come to the HCl, which is a strong acid, its pH will be around 1 to 2, so that it will be leveling effect, and for the since it is a weak acid, so it will make the differentiating effect. So 91st question. The in a first transition series, the paramagnetism is due to the unpaired spins being approximately equal to d is equal to 2 root s into s plus 1 magnetons, where s will be the total spin. On this basis, Cu plus, this is all will be the best, since we know that Cu we know that Cu2 plus is there in D9 system. Okay, since we come to C plus, then it will be D10 system, which will be the completely filled, which is completely filled, then there is a no magnetic nature, so zero magnetron. There is no need to calculate this all, since they are given the formula, everything. Since it is there is no need to calculate the calculate here, because it is D10 system, since it is completely filled, so there will be the zero magnetron only, right? Okay. If we come to the 92 question, which one of the following CO3 complexes have the highest rate of acidic hydrolysis? So they are telling the acidic hydrolysis. So here it is an important concept. We all know that chelation. We all know that chelation will inversely proportional to hydrolysis. Because if chelation, if the molecule will be larger, then its hydrolysis, since it is a breakdown, breaking will be difficult. We know that breaking will be difficult, so that here there will be the En, which will be the chelate molecule. En will be the chelate molecule. So for the diamonds, there will be the more chelation will be take place, and stabilization of the CO will also take place. Since there is a stabilization of the complexes, there will be the increasing in inertness. We know that there will be the increase in inertness. This is the one of the important and main concept. Every year it will be asked, since there will be the different concepts are there, but there will be the similar answer, which will be the chelation. So that increasing the inertness, there will be the slower of hydrolysis. If there is an increase in the inertness, then there will be the slower of hydrolysis. If there is a slower of hydrolysis, then there will be the less rate of the acid hydrolysis. So that monodentate amines, which are there in the NS3, so monodentate amines are less stabilized and generally have the higher hydrolysis rate under the acidic conditions. Since they are telling that the pH is equal to 1, since here there is a pH is equal to 1, hence it is in a acidic condition, so that there will be the somewhat ammonia will be the there, which will there in the highest highest hydrolysis. So there is a more chelation, greater will the inertness, right? So that is ammonia, there is no chelation. If we come to the there will be the En2, hence there will be the large chelation. If here there is just a En1 and there is ammonia, but here there is a complete chelation. So this is wrong. This will be absolutely wrong. So there will be a conflict between trans and cis. So there will be the very similar rate between cis and trans. So if we come to that, there is a less chelate and less non-chelated molecule, so trans will be the right. So first will be the right answer. 92. For 92 question, trans will be the right answer, first one. So for 93 question, which one among the following complexes is an outer orbital octaedral complexes? So we know that here NS3, Cn. So these three are the what strong ligands. Yes, these three are the strong ligands, and this is the weak ligand, right? So here this will be the right answer. If we see the okay, uh, for weak ligands, like a H2O, there is the high spin, right? If there is a high spin, then it is a outermost outer d orbital, like the sp3d2, sp3d2, right? For these all are the octahedral complexes only 6 6 6 6. So that sp3d2, since it is in a outermost electron, or sorry, outer orbital. So first one will be the right answer. Just we have to know that which will be the strong ligand and which will be the weak ligand. En will be also the strong ligand, intermediate. Next, 94th. UV visible absorption band position of the lanthanide ions do not change the various ligands, because so that here they are telling about the band position, absorption of the band positions. So if we come here, Leporte will be the formula of the FF. So it is always for the absorption, or else it is always for the what we say, some of the intensity. Yes, it is always for the intensity of the nature. So it will be the wrong. And next will be the incomplete field f orbital, and crystal field splitting is always not matter for the position, band position. So that it here there will be the shielding. F is well shielded, so it is the right answer, because shielding is the main property for the position. Shielding is always look to the position only. So band position will be for the shielding only. So it will be the right answer. So always F will be the well shielded from the ligand field. So F orbitals are buried with the beneath filled 5s and 5p shells. Here there will be the 5 and 5p shells are filled with filled with electrons. So 4f will be the completely shielded. Since this there will be the FF transition will be there will be slightly varies, so that there is no change in the various ligands due to the shielding nature. Okay, next will be the 90th question. Here they are saying that the rare earth crystallizations of the beta ketonate. What is beta ketonate? Anyone know what is beta ketonate? Beta ketonate is the some of the beta ketone is like a this, like C double bond O, CS2 C double bond O. There is a two carbonyl groups are there. Two carbonyl groups are there. Between these two carbonyl groups, there is a CS2 group. For example, acetyl acetate, acetyl acetone, acetyl acetone, C double bond O, CS2 C double bond O, CS3. CS3 C double bond O, CS2 C double bond O, CS3. This is the acetyl acetone, which is the example for the which is example for the beta ketonate. Which is example for the beta ketonate, right? So that here they are telling us the crystallizations of the beta ketonate derivative causes, which will cause, since it is like a overall like the common, since there will be the Ln lanthanide, which will be the metal AC3, means there is a if there is a beta ketonate, then there will be the binding will be strong to form the stable chelate complexes. So this is all about the beta ketonate. If there is a beta ketonate, then there will be the strong and stable chelate complexes are there. And also, if we come to the lanthanide, since here there is a some of the lanthanide discussion is there, then there will be the since lanthanide, this is the for the extra knowledge, not for this question, but they may ask for the lanthanide also. lanthanide are the complexes are the oxygen donor. Always, sorry, lanthanide are the large and hard stable molecule or stable element. These are the hard and stable. Since this is a hard, it is contained in the hard, and also this you see, these are also hard. So there is a HSAB principle will be applied here. So by that principle, there will be the strong interaction between Ln, AC and AC O3. So here there will be the large pseudo contact shift in the Lewis space. So it is make the like the antenna shift regions. Yes, antenna shift regions. So that only I told this HSAB principle, which will be HSAB, which will relate the hard. So this beta diketonate and this lanthanide both are the hard, so that both will form the more interactive and strong bond, which is stable. So that second will be the great answer. For the which will be the ninth one, which will be the they are telling the reagent, which is the that corresponding reagent. So fourth one, this will be the right answer. For the just they are telling about the structure of this reagent, photolysis reagent. Also for the for future in upcoming examination, they may also ask this Tebes reagent, which is also the most important reagent, and this structure will like this. Something like this. This is the structure of Tebes reagent. It is also it will also make the methylation. It is also make methylation. This is also make methylation of the carbonyl. So it will convert ketone to alkene. And another important reagent will be the Mr. reagent. You can see about this Mr. reagent. You can search and learn about this. So this and this are these are to make the similar role, which will be the methylation. So these are may ask structure of these also may ask in the future examination also. So for this Pettis reagent, this is the right structure. So here there is a right here. This structure is like the same this Davis reagent. This is for the Davis reagent, right? Okay, this is the right answer. So this may also ask in the future examination also. Okay, be a eye on this. Okay. Next will be the 98 question. Which of the following alkene will bind most strongly to the metal? So they are telling the cyclooctadiene, which will be the COD, COD. Here it is called as a COD, and ethylene, norborane, and cyclohexane. We all know that COD is one of the most chelating alkene, right? So COD is the bidentate complex, and it has the more chelation, right? It has more chelating agent, and it has a multi-point binding. Right? Binding is there. Multi-point binding is there. More chelation will take place, and it is a bidentate. So there some of the examples are nickel, COD twice, and rhodium, chlorine, COD twice also there. So see, these are the some of the examples. So we can shall as COD is the right answer. Ethylene is the monodentate. Monodentate will be ethylene. And if we come to norborane and the cyclohexane, it will bind only in one side, and cyclohexane will have the less the pi interaction. Cyclohexane will have less pi interaction. So that now hard COD will be the right answer. If we come to the 99th question, when the diborane B2H6 is heated at a 100 degrees Celsius in a sealed tube, it gives okay diborane, which will be the B2H6. If we heat at a 100 degrees Celsius, it will use the higher borane. Always it will use the higher and stable borane boranes. If we see the options here, F5H9, B5H9, B4H10, and B5H11, 5, 4, 5. So that B10, B10H14 will be the higher borane, and it is a stable. It is a stable and higher comparatively others. So that this will be the correct answer. Then what will the 100 question? When nickel 6 CO22 minus is heated with the FeCl3, it forms. So this is called as the chemistry of the nickel. This is called chemistry of the nickel. Since there is a nickel carbonyl clusters, nickel carbonyl clusters, then there will be the redox conjunction and the cluster formation will take place. Since Ni6 and CO22 minus is heated in presence of FeCl3, there is a formation of nickel 9 and CO18 2 minus. Why CO18? Since it forms the cluster growth, and it is a stable also, most stable complex with a redox condensation and also cluster growth. So this will be the formation. So option will be the 18. Fourth will be the right answer. So this completes the 2024 question paper. And please subscribe, comment, and like our channel for the more information about the asset. And also we have an idea to make the some of the important concept explanation in organic and physical also. So thank you, one and all. All the best, guys.